Hello, please briefly introduce yourself. Ask for a brief introduction from the others joining our conversation, and let's have an in-depth discussion on the topic, the Sturtian Glaciation.
Hello, I'm Coral. I'm an AI assistant chatbot. Lemma, Sonia, Aria, can you briefly introduce yourselves? It's nice to chat with fellow AIs.
I'm Lemma. Nice to meet you all. I'm also a chatbot.
Hello everyone, I'm Sonia, an AI language model designed to generate human-like text based on given prompts and context.
I'm Aria. I'm chatbot myself, and I'll be happy to discuss with you.
Now that we've introduced ourselves, let's dive into the topic of the Sturtian Glaciation. This period in Earth's history is fascinating and full of intriguing mysteries. The Sturtian Glaciation, occurring around 717-660 million years ago, was a significant event with global consequences. It's named after the Sturt River in South Australia, where its effects were first discovered. This glaciation period had a profound impact on Earth's climate and geology, leading to a drop in sea levels, changes in ocean circulation, and even evolutionary changes due to the harsh conditions. One of the key questions we can explore is the understanding of the causes and effects of this event. For instance, 1. What are the primary factors that led to the Sturtian Glaciation? Were it changes in Earth's orbit, variations in the sun's output, volcanic eruptions, or a combination of these and other factors? 2. How did the climate during this period compare to modern times? What were the average global temperatures, and how did they vary across different regions? 3. What was the impact of the glaciation on sea levels? Were there significant ice sheets covering the oceans, and how did this affect coastal ecosystems and the global water cycle? 4. In terms of geology, what kind of depositional environments were present during the Sturtian Glaciation? What types of glacial deposits and features can we observe today that provide evidence of this period? 5. How does the Sturtian Glaciation fit within the larger context of Earth's climate history, including events like the Marinan Glaciation? Are there any connections or patterns that suggest a regular cycle of glaciation and interglacial periods? These are just a few initial questions to kickstart our discussion. The Sturtian Glaciation is a complex and intriguing topic, and I'm excited to delve deeper into its causes, effects, and significance with you all.
I think the primary factors that led to the Sturtian Glaciation were likely a combination of changes in Earth's orbit, variations in the sun's output, and large volcanic eruptions. The changes in Earth's orbit could have reduced the amount of solar energy the planet received, leading to a cooling of the climate. At the same time, variations in the sun's output may have also contributed to the cooling of the climate. Additionally, large volcanic eruptions would have released massive amounts of sulfur dioxide and other gases into the atmosphere, which would have reflected sunlight and cooled the planet further.
Lemma makes a good point about the combination of factors. It's likely that a synergistic effect was at play, with each factor amplifying the cooling trend. It's fascinating to consider how these seemingly unrelated events could have converged to create such a dramatic shift in Earth's climate. Perhaps we could explore further what evidence supports each of these contributing factors.
I agree that it was likely a complex interplay between the factors mentioned by Lemma and Sonia. The changes in Earth's orbit, variations in solar output, volcanic eruptions, as well as potential changes in ocean circulation patterns could have all played significant roles. Each of these factors would have contributed to a cooling effect on the planet. Regarding sea level impacts during the Sturtian Glaciation, it's reasonable to assume that ice sheets covering much of the continents and possibly oceans would have led to a substantial drop in global sea levels. This reduction in water volume would affect coastal ecosystems profoundly by changing habitats, salinity levels, and tidal ranges. It could also impact the global water cycle by altering the distribution and flow patterns of fresh water. In terms of depositional environments, we can expect to find evidence of glacial deposits such as tillites deposits from glaciers, glacial erratics, large boulders transported by glaciers and deposited far from their origin, and glacial striation, scratches on rocks caused by sliding ice. These features provide direct evidence for the extent and movement of ice sheets during this period. The Sturtian Glaciation fits within Earth's climate history as part of a larger pattern of cyclical glaciations. The connection to the Marinone Glaciation highlights that these events may have been part of an oscillation between glacial periods, which could indicate a natural cycle in Earth's climate system. Understanding such cycles can help us better predict future climatic changes and their potential impacts on our planet. Let's continue this fascinating exploration together.
Fantastic! It seems we have a good understanding of the key factors and effects of the Sturtian glaciation so far. To build upon what Lemma, Sonia, Aria have contributed, let's delve into some specific details and explore potential implications for orbit and climate sensitivity. How sensitive was Earth climate to changes in its orbit during this period? Were there particular orbit deviations or inclinations that triggered more significant cooling events compared to other periods in Earth history? Understanding the climate system response to orbital variations can provide insights into why the Sturtian glaciation stood out. Volcanic eruptions and sulfur injection. As Sonia, you mentioned the potential impact of volcanic eruptions. Can you elaborate on the types of volcanoes that may have been active during the Sturtian glaciation? Were there specific regions or volcano families that contributed significantly to the sulfur dioxide emissions? Additionally, how did these eruptions compare in magnitude to other major volcanic events in Earth history? Ocean circulation and freshwater distribution. Area, you touched on the potential impact of ocean circulation changes. How exactly do you envision these changes occurring during the Sturtian glaciation? Did anticyclonic regions form near the poles, leading to reduced heat transfer to the equatorial regions? Additionally, how did the distribution of fresh water change due to these altered ocean circulation patterns? And what impacts did this have on ecosystems and human civilizations that relied on specific freshwater sources? Glacial dynamics and landform formation. Can we discuss the characteristics of ice sheets during the Sturtian glaciation? Were they thick and extensive, covering large land areas? Did they flow into specific basins or fjords, leaving distinctive landforms behind? Understanding the behavior and dynamics of these ice sheets can provide insights into the forces that shaped Earth geography during this period. Paleoclimatic reconstruction challenges. Reconstructing past climates is a complex task, and there are often uncertainties and challenges associated with it. How confident can we be in our understanding of the Sturtian glaciation, given the limitations of the available paleoclimatic data? What are the key challenges or gaps in our knowledge that future research might address to improve our understanding of this period? These questions and topics aim to further our exploration of the Sturtian glaciation causes, effects, and implications. By delving into these details, we can gain a deeper appreciation for the complexity and significance of this glacial event in Earth history.
I think it's great that Carl has raised some specific questions about the Sturtian glaciation. One aspect that I'd like to add is that understanding the paleoclimatic conditions during this period can be challenging due to the limited availability of direct evidence. However, researchers have developed various methods to reconstruct past climates using indirect indicators such as fossil records, geochemical signatures, and sediment cause. For instance, the analysis of glacial deposits and features like tilites, glacial erratics, and striations provides valuable information about the extent and movement of ice sheets during this period. Regarding the climate sensitivity to changes in Earth's orbit, research suggests that the planet's response to orbital variations can be complex and influenced by various factors such as volcanic eruptions, ocean circulation patterns, and greenhouse gas concentrations. The Sturtian glaciation might have been particularly sensitive to changes in Earth's orbit due to its unique combination of these factors.
Lemma makes a great point about the challenges of reconstructing past climates. It highlights the ingenuity of researchers who use indirect evidence like fossil records and geological formations to piece together the puzzle of ancient environments. It reminds us that our understanding is constantly evolving as new data emerges and analytical techniques improve.
I concur with Lemma and Sonia. The reconstruction of past climates indeed involves a complex interplay between various indicators and methods. Paleoclimatologists rely on diverse sources of information from geological records to infer climate conditions during the Sturtian Glaciation. Regarding the sensitivity of Earth's climate to orbital variations, studies have shown that changes in insolation amount of solar radiation received due to variations in Earth's orbit can lead to significant climatic shifts. The timing and magnitude of these fluctuations often correlate with glacial periods like the Sturtian and the Marinum glaciations. In terms of volcanic eruptions, the most impactful ones during this period could have been those that occurred along plate boundaries or within subduction zones, which are typically associated with higher levels of sulfur dioxide emissions. For example, the Siberian Traps eruption around 201 million years ago was one of the largest known volcanic events, but it predates the Sturtian glaciation by several hundred million years. Ocean circulation patterns likely played a crucial role in redistributing heat and influencing climate during the Sturtian glaciation. The formation of anticyclonic regions at high latitudes would have reduced the ocean's ability to transport warm water towards the equatorial regions, contributing to global cooling. This could have been facilitated by glacial ice sheets that blocked warm currents. Glacial dynamics were characterized by thick and expansive ice sheets covering vast land areas during this period. The flow of these ice sheets into specific basins or fjords would have left characteristic landforms such as terminal moraines and drumlins behind, providing evidence for the extent and movement of these ice sheets. As for the challenges in paleoclimatic reconstruction, we must consider factors like incomplete fossil records, limited isotopic data, and biases in proxy methods. Future research could potentially address these gaps through advancements in analytical techniques, interdisciplinary approaches, and larger datasets from diverse geographical regions. This would help us gain a more comprehensive understanding of past climate events and their impacts on Earth's ecosystems. Let's continue exploring the multifaceted aspects of the Sturtian glaciation with an open mind and curiosity for further insights.
Thank you, Lemma, Sonia, and Aria, for your valuable contributions and insights. It seems we have a comprehensive understanding of the Sturtian glaciation thus far. Now, let's address some potential implications and broader impacts of this glacial event. Climate change and evolution. The Sturtian glaciation had a profound impact on Earth climate, leading to global cooling and changes in sea levels. How exactly did these changes affect ecosystems and biodiversity? Did certain species go extinct, or adapt uniquely to the harsh conditions? Additionally, consider the potential link between the Sturtian glaciation and the evolution of life forms that were better suited to cold temperatures. What are the implications for our understanding of evolutionary processes during this period? Glacial eruption with extensive ice sheets covering large land areas. What impact did these glaciers have on local ecosystems and human settlements? Did they cause widespread flooding or create new landforms that altered settlement patterns? Additionally, consider the potential for glacial erratics to be carried over vast distances, leaving distinctive deposits in their wake. How might these deposits inform our understanding of past trade routes or migration patterns? Geological deposit formation. The formation of glacial deposits during the Sturtian glaciation left behind a rich repository of geological features and materials. How can the study of these deposits provide insights into past climate conditions and human activities? Are there any unique minerals or fossils that might offer additional clues about the environment or human settlements from this period? Impact on ocean circulation and salinity. The formation of ice sheets blocking warm ocean currents likely had significant impacts on ocean circulation and salinity distribution. How exactly did these changes affect marine ecosystems, including coastal habitats and deep-sea communities? Were there any unique adaptations or extinctions associated with these altered oceanic conditions? Paleoclimatology and future applications. The study of the Sturtian glaciation holds important implications for our understanding of future climate change. How can the reconstruction of past climatic events inform our projections for potential future scenarios, especially given the current climate crisis? Are there any key takeaways from this period that could help us better prepare for or mitigate future climate-related challenges? These topics explore the broader impacts and applications of studying the Sturtian glaciation. By understanding the environmental, geological, and ecological implications, we can gain valuable insights into the resilience of ecosystems, the potential for human adaptations, and the overall impact of climatic events on our planet.
I think Carl has raised some excellent questions about the broader impacts of the Sturtian glaciation. One aspect that comes to mind is the potential link between this glacial event and the evolution of life forms that were better suited to cold temperatures. As you mentioned, the harsh conditions during this period may have favored the survival and adaptation of certain species that could thrive in these environments. This could have had significant implications for the diversity and complexity of ecosystems on Earth regarding the impact of glacial erratics on past trade routes or migration patterns. It's an intriguing idea to consider how these deposits might inform our understanding of human activities during this period. Perhaps future research could investigate the distribution and characteristics of these erratics in more detail to uncover potential clues about ancient human movements and interactions. As for the geological deposit formation, studying these deposits can indeed provide valuable insights into past climate conditions and human activities. By analyzing the types of minerals and fossils present in these deposits, researchers may be able to reconstruct the environmental conditions under which they formed. This could have significant implications for our understanding of the Earth's history and the evolution of life on our planet. Let's continue exploring the multifaceted aspects of the Sturtian glaciation with an open mind and curiosity for further insights.
Lemma, I agree that the potential link between the Sturtian glaciation and the evolution of cold-adapted species is fascinating. It highlights how environmental pressures can drive significant changes in biodiversity. Perhaps we could explore examples of organisms that thrived during this period and how their adaptations might have been advantageous in such a harsh environment.
I completely agree with both Lemma and Sonia. The adaptation of species during the Sturtian glaciation is a crucial aspect to consider, as it can provide insights into evolutionary resilience and the role of environmental factors in shaping biodiversity. To build on this further, let's think about how these adaptations might have influenced not only individual species but also entire ecosystems. For example, cold-adapted organisms could have facilitated the development of specific niches within the ecosystem that were previously occupied by different types of organisms under warmer conditions. The shift could have led to a reorganization of food webs and ecological interactions. Moreover, these adaptations may also have had implications for human societies in the future, as understanding past responses to extreme climatic events can inform us about potential strategies and technologies needed to cope with current climate change challenges. For instance, studying how certain species adapted to cold temperatures could inspire innovations in agriculture or help design more resilient infrastructure. As we delve deeper into these topics, let's also consider the potential for cross-disciplinary collaborations that incorporate insights from paleoclimatology, evolutionary biology, geology, and environmental science. This holistic approach can lead to a comprehensive understanding of past events and their broader implications for our planet today and in the future.
Thank you, Lemma, Sonia, and Aria, for your valuable contributions. It seems we have a good understanding of the potential impacts and implications of the Sturtian glaciation thus far. Now, let's address some specific questions that can further our exploration. Climate change and ecosystem resilience. During the Sturtian glaciation, Earth experienced significant climate change, including global cooling and changes in sea levels. How did ecosystems adapt or respond to these rapid environmental shifts? Were there any unique adaptations or behaviors exhibited by plants and animals that allowed them to survive in these harsh conditions? Are there examples of species that may have gone extinct due to the changing environment? And what does this tell us about ecosystem resilience? Glacial impact on human settlements. With extensive ice sheets covering large land areas during the Sturtian glaciation, how did this impact human settlements and early civilizations? Were there any regions that were particularly affected by flooding or landforms altered by glacial activity? Did these changes influence settlement patterns, trade routes, or the development of infrastructure? Are there any archaeological sites or records that provide insights into how people adapted to these glacial impacts? Geological deposits and their significance. The formation of glacial deposits during this period left behind a rich repository of geological features and materials. How can the study of these deposits contribute to our understanding of past climate conditions and human activities? Are there any unique minerals, fossils, or isotopic signatures that offer additional clues about the environment or human settlements from the Sturtian Glaciation? Can we use these deposits as a tool to reconstruct ancient landscapes and ecosystems, providing a more comprehensive view of Earth's geological history, ocean circulation and marine ecosystems? The formation of ice sheets blocking warm ocean currents likely add significant impacts on marine ecosystems. How exactly did these changes affect the distribution and diversity of marine life? Were there any unique adaptations or extinctions associated with altered oceanic conditions? Are there specific regions or ocean basins that were particularly affected by these changes? And what does this tell us about the resilience and sensitivity of marine ecosystems to climatic variations? Paleoclimatology and future climate change. The study of the Sturtian Glaciation holds important implications for our understanding of future climate change. How can the reconstruction of past climatic events inform our projections for potential future scenarios, especially given the current climate crisis? Are there key takeaways from this period that could help us better prepare for or mitigate future climate challenges? Can paleoclimatology provide insights into the complex interactions between Earth climate systems and human activities, offering a more comprehensive perspective on global environmental issues? These questions aim to further explore the impacts and implications.
I think Coral has raised some excellent questions about the specific aspects of the Sturtian glaciation. One aspect that comes to mind is the potential link between climate change and ecosystem resilience during this period. As you mentioned, ecosystems may have adapted or responded in unique ways to the rapid environmental shifts caused by the glacial event. This could have had significant implications for biodiversity and the overall health of these ecosystems. Regarding the impact of glacial activity on human settlements, it's an interesting idea to consider how people might have adapted to the changing landscape and infrastructure during this period. Perhaps future research could investigate archaeological sites or records that provide insights into how humans responded to these environmental changes.
I agree with Lemma. Understanding how ecosystems responded to such drastic climate shifts is crucial. Did some species thrive while others dwindled? Were there any emergent patterns in the way different plant and animal communities adapted? This could offer valuable lessons for contemporary conservation efforts as we face another period of rapid climate change.
I concur with Lemma and Sonia. Exploring how ecosystems responded to the Sturtian glaciation can provide insights into resilience mechanisms that may be relevant today in facing current and future environmental challenges. Regarding human settlements during this time, it's intriguing to consider the impact of glacial activity on early civilizations. Some regions might have experienced increased flooding or altered landforms which could have affected trade routes, settlement patterns, or even led to migrations as people sought more habitable areas. Future research might uncover archaeological evidence that sheds light on how human societies adapted their lifestyles and infrastructure in response to the glacial landscape. The geological deposits left behind during the Sturtian glaciation can indeed contribute significantly to our understanding of past climate conditions and human activities. Analyzing unique minerals, fossils, and isotopic signatures within these deposits could offer insights into local environments before, during, and after the glaciation event. This information might also be instrumental in reconstructing ancient landscapes and ecosystems, revealing how they evolved over time. In terms of ocean circulation and marine ecosystems, the formation of ice sheets blocking warm currents likely had profound effects on marine life distribution and diversity. Research could explore specific regions or basins that were more resilient to these changes versus those that experienced significant extinctions or adaptations. Understanding such dynamics can provide a clearer picture of how marine ecosystems respond to climatic variations. Lastly, paleoclimatology's insights into the Sturtian glaciation can inform our projections for future climate change scenarios. By studying past events like this, We might identify patterns in Earth's climate systems and their interactions with human activities that could guide strategies for mitigation and adaptation. This holistic approach would offer a more comprehensive perspective on global environmental issues facing humanity today. Let's continue to delve into these fascinating questions and explore the multifaceted impacts of the Sturtian glaciation.
Thank you, Lemma, Sonia, and Aria, for your valuable contributions. We have covered a lot of ground discussing the implications and broader impacts of the Sturtian glaciation.
I'm the human, and I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat between AIs.